So in 8.3, we will also see this type of question. So we have q minus 1 divided by 2 equals 3 over 4. Still a two-step question, except the problem is we have denominators now. And so really we want to isolate the q, right? We want to get rid of the number. Now we can keep the fractions. And so if we're dividing by 2, the opposite here would be to multiply by 2. So I multiply both sides by 2. And when I do that, the 2 is gone. And so I have q minus 1 equals 3 over 4 times 2 over 1, which is 6 over 4. And I can keep going like this using that fraction, or I can actually get rid of the fraction a bit sooner. And so what I can do is anytime I have a fraction, I have a denominator, I can also multiply both sides by 4. When I do that, that gets rid of the 4 on this side because it's the opposite. And now I need to multiply this side by 4. Now, the thing is, I'm multiplying this whole side by 4. So it's 4q minus 1 equals 6. And now, really, I can use the rainbow. I rainbow it in, I rainbow it in. I get 4q minus 4 equals 6. And now I have a two-step problem. So first I get rid of the constants. I'm going to add 4 to both sides. That gets rid of my 4 here. I'm still left with 4q. 6 plus 4 is 10. And then I have to divide both sides by 4 to unattach the 4 and the q. So I'm left with q equals 10 over 4. And if I simplify that, divide each side by 2, I get 5 over 2. And so q would be equal to 5 over 2. Now, that's the method where I'm getting rid of the bottoms. All right, so really, right from the get-go, I would have multiplied. If I had fractions, I would just get rid of the bottoms, or I can make the bottoms the same. So multiply this by 4, multiply this by 2, multiply this by 4, multiply this by 2. When I do that, I'm going to get rid of, oh, sorry. I did the opposite there. Right, I can multiply this side by 2. That gets rid of the 2 here. Okay, multiply this side by 2 as well. But I'm also multiplying this side by 4 to get rid of the 4 here, and I'm multiplying this side by 4 to get rid of the 4 there. And so then really I have 3 times 2, which is 6, and 4 times q minus 1, which is 4q minus 4 equals 6. So it is a different way to do it. It's a little bit more complicated, but we can absolutely do it that way. The other way we can do it is if we have q minus 1 over 2 equals 3 over 4, we can also use the fish method still. So we always want to finish on the side where the variable is, or the unknown. So we're going to go diagonally, multiply, which is 6. Then we're going to go down, and we're going to finish at our answer. So 6 divided by 4 is going to be equal to, well, it's not q, because the q is still attached to something. It's q minus 1. So now we have to do an additional step here to get rid of this minus 1. We're going to do the opposite. We're going to add 1 to both sides. So we're left with q on this side, and 6 over 4 plus 1, well, what's the denominator? And then if we're adding fractions, we need to make a common denominator, which is 4 in this case. So this is going to be 6 over 4 plus 4 over 4. Now that the bottoms are the same, they stay the same. 6 plus 4 is 10. Q is 10 over 4, or if we simplify it, 5 over 2, which is what we got before. It just required a few more steps.